Let's talk now about multiplying polynomials. We're going to begin by looking at multiplying monomial terms. Let's say you have something like 2x to the power of 3 times 4x to the power of 5. Right, now, 2x to the power of 3 is in itself a multiplication. 2x to the power of 3 is 2 times x to the power of 3. Likewise, 4x to the power of 5 is like saying 4 times x to the power of 5. So all of these are just one big set of multiplication problems. But when you multiply, multiplication is commutative, meaning you can multiply in whatever order you want. Multiplying 2 times 3 times 4 is the same as multiplying 4 times 3 times 2. Well, same thing is true if you have constants with variables. You can multiply in whatever order you like. So here, you could rearrange it so that the numbers were together and so that the variable expressions are together. Oh, but now, these two multiply together as regular numbers. 2 times 4 would give us 8. These multiply together. When you have two things that have the same base, you multiply them by adding their powers. So that would give us 8x to the power of 8. If these coefficients happen to change, if they're positives, negatives, fractions, whole numbers, or decimals, none of that will change. Likewise, if these variables change their powers, again, none of that will change. So as another example, let's say you have negative 5 x to the power 4 times 6x to the power 3. Well, again, you could rearrange things to put the numbers together. And the product of those numbers, negative 5 times positive 6, is a negative 30. Meanwhile, if you multiply these together, same as before, when you multiply two things that have the same base, you simply add their powers. So x to the power 4 times x to the power 3 is x to the power 7. Just like that. Now remember, in order to do that, in order for us to be able to add these two powers, that does require us to have two expressions of the same base. So if ever you have things that have a different base, so for example, 4x to the power 5 times 6x, let's say 6y to the power 8. Here, we could do the same thing. We could say we could say 6 times 4, that'll give us 24. And then we can say x to the power of 5, y to the power of 8. Because here, we can't combine these. We can't say x to the power of 4 times x to the power of 3 is x to the power of 7, because here these have a different base. And when they have a different base, you can't combine them by adding their powers. They're too different from each other. So here we simply write them as, okay, let's combine what we can. 4 times 6 is 24. X to the power of 5 times y to the power 8. And there we go, there's our product. Okay, so this is what happens when you multiply monomial times another monomial. But what happens when you have something bigger? Let's say, for example, we had something like a monomial times a polynomial. And it doesn't really matter what polynomial we have, but here I'm going to start off with a binomial. So a monomial by a polynomial. So for example, something like 2x to the power 4 times 3x minus 12. Okay? So here is a monomial. It's only got one term. And here is a binomial. This isn't anything reserved specifically for binomials. If we had a trinomial or any other polynomial, that would be fine. Okay, how do we do this? Well, it's the same way we always multiply numbers. Well, how do we always multiply numbers? Well, consider something like this. So you had 2 times 34. How do you multiply that? Well, let's see. If I had 34 times 2, I would say 2 times 4. Well, that'll give me 8. And then 3 times 2 is going to give me 6. Okay, that'll give me 68. Okay, but if it's written sideways like this instead of up and down, that's not going to change the answer. And in fact, look, I could still say 2 times 3 and 2 times 4. That's going to give me 2 times 3 is my 6, 2 times 4 is my 8. Okay, but, well, That's not really the number 3, though, is it? It's the number 30, right? 34, that 3 stands for the number 30. So you could also think of it this way. You could say, well, that's 2 times 30 plus 4. That's true. That's 34 times 2, same as these other examples. Well, I could do the same thing. I could say 2 times my 30, that's my 60, and 2 times my 4, that's my 8. And when I add those together, that'll give me 68. Notice it's the same answer no matter how I want to think about it. I can think about it vertically or horizontally, or I could even think of it as this number multiplies that 30, and then separately it multiplies that 4, and then I add those together. This is the way we want to think about it for the purposes of these kinds of problems, because it'll maintain the same pattern. The way we do this is we're going to take this monomial, and just like we took this 2 and multiplied it into the 30 and then multiplied it into the 4, we're going to take this monomial, the 2x to the power 4, and we're going to multiply it times the 3x, and then we're going to multiply it times the negative 12. This process of taking a number or an expression and multiplying it times several different terms of a polynomial, this is called distribution. This is called distribution. It's how we multiply with polynomials. All right, so let's do that. Here, if I multiply together 2 times x to the 4th times 3x. All right, well, let's see. Let's do that first. 2 times 3 is going to give us 6. X to the 4th times x. Remember, x is the same as saying x to the first power. So that's 4 plus 1. That'll give us x to the power 5. Now, we're going to go ahead and distribute here. We're going to multiply this 2x to the 4th and this minus 12. Okay, so we're going to have 2x to the 4th minus times, let me put the minus here in the front. So that's negative 12 times that 2x to the 4th. Okay, well, a negative times a positive, that's a negative. 12 times 2 is 24. And then x to the 4th, that doesn't have any other variable to combine with, which means it has no reason to change. So there we go. There's our result. This is called distribution. We are distributing this expression. All right, let's see that again. Let's say I have 3x to the power 5 times, let's say 6x to the power 4 minus, let's say plus 9x squared minus 5. Okay. Notice here I have a trinomial, and that doesn't change things, because over here, if I added one extra number, if I instead of saying 34, I said 134, well, so what? I would just have to multiply that 2 times one more digit. Oh, okay, so over here, I would have to multiply again by just one more digit. So the distribution happens to each term in our polynomial. All right, so let's see what happens. We're going to go ahead and take this expression, the 3x to the power 5, and we're going to distribute it one at a time into all 3 of our terms. If we had 4 terms, we would distribute to 4 terms. However many terms we have, we're going to distribute this into all of them. Okay, so 3 times 6, that'll give me 18. X to the power 5 times x to the power 4 will give me x to the power 5 plus 4. In other words, x to the power 9. Now here I have a 3 times a 9, that's 27. Now remember, this is going to form a polynomial. Whenever you have polynomial terms, all terms should either be have a plus or a minus in between, either added or subtracted like this. So when we say 27, we mean plus 27. You can't just write it down this way. It needs to be added together to form a polynomial. So 3 times 9 is 27. Since that's a positive, we mean plus 27. X to the power 5 times x to the power 2 is x to the power 7. And then we distribute one last time. That's a positive 3 times a negative 5. Okay, that's a negative 15. Notice that x to the 5th doesn't have any other variables to combine with, which means there's no reason to change that x to the 5th. So we just leave it as x to the 5th. And that is our result. So go ahead and give this a try. Go ahead and multiply the following. 6x to the power 2 times 4x to the power 2 minus 9x plus 8. Okay? Go ahead and multiply. We're going to do that by distributing. The process is called distribution. What you're doing is you are distributing. And once you are done, go ahead and unpause the video and we'll go through it together. All right, so let's take a look. We're going to take this monomial and we're going to distribute one at a time into 1, 2, 3 terms. All right, so let's see what we get. 6 times 4 is 24. X squared times another x squared is x to the power 4. When you multiply two things that have the same base, their powers get added together. Okay? 6 times negative 9, that's negative 54. X squared times x. Remember, x is like saying x to the first power. So when you add the 2 and that power 1, that'll give you x to the power 3. And finally, if you multiply these together, 6 times 8 will give us positive 48. So we're going to put a plus there, plus 48. This x squared has no variable to cause it to change, and so we're going to leave it as x squared. And that is our result. 24x to the fourth minus 54x to the third plus 48x squared. Just like that. Note that if we have a different variable, we can have things like here where you end up having more than one variable within a term, and that's okay. So for example, let's say we multiply together 3x squared times, let's say we have 4x plus 5y minus 6. You can tell I work very hard to come up with examples, right? 3, 4, 5, 6. Oh, but I have a negative in there, so I worked extra hard today. We're going to go ahead and distribute. This multiplies across all of our terms. Whether you have 2, 3, 4, 5, 6, doesn't matter. However many terms, we're going to distribute across all of them. So now here we go. 3 times 4 will give us a 12. X squared times another x is x to the power 3. Okay. Now the next term. 3 times 5, that's a positive 15, so I'll say plus 15. Notice I can't combine those. X squared and y, they have a different base. So I can't say x to the third like I did before. I can't say y to the third. I have to keep those separate. So this will be 15 x squared y. And finally, when we distribute here, negative 6 times 3 is negative 18. And since this doesn't have any variables, that x squared stays the way it was. And that's our result, 12x to the third plus 15x squared y minus 18x squared. Now what happens if I have even more terms? You say, well, you just distribute all the way across if you have a fourth or a fifth term. Well, yeah, but what if we have more terms here? Well, going back to how regular multiplication works with regular constants, what happens if I were to add another number here? Say, for example, I had 34. Instead of times 2, let's say I had times 12. Well, let's see. 2 times 4 is 8. 2 times 3 is 6. Oh, but I'm not done yet. Because now I have to multiply 1 times 4. That'll give me 4. And 1 times 3 will give me 3. Oh, but I'm still not done. Because once I've distributed this number into those two digits, and then once I distribute this number into those two digits, I still have to add my numbers together. Notice my ones go with my ones, my tens go with my tens, and my hundreds go with my hundreds. So here, we're still going to distribute. This number will multiply across both of those. But you're not just going to distribute one number, you can distribute both of them. Oh, but once you're done, what you need to do is you need to add together whatever can be added together. Think about it this way. 34 is like saying 30 plus 4. 12 is like saying 10 plus 2. And when we multiply, look what happens. We're going to take the 2 and multiply it across both of those. Okay, well that's 2 times 30. That's 60. And 2 times 4, that's 8. Oh, but then I have 10, that 1 right there, which represents the number 10. That's going to multiply across both of those. So 10 times 30, that's what, 300? And then 10 times 4, well, that's going to give us 40. But then once I've multiplied all of those by distributing, what do? Well, I add everything together. 300, 60, and another 40. Well, that's 400. 400 plus 8. That's 408. Like that, yeah? So the way we multiply out 2-digit numbers, or 3, or 4, or 5-digit numbers, is we distribute, not just one digit, but all of them. And then once we're done distributing, we add things together. Well, that's the same way we're going to do it with a polynomial times another polynomial. So that's what we're doing now. Let's talk about how you multiply one polynomial times another polynomial, something that has more than one term. Let's consider, for example, x plus 5 times x minus 6. We're going to follow this pattern. We're going to say, take this x and distribute it across all terms of this polynomial. Okay, so I'm going to have x times x. That's going to give me x squared. And then I'm going to have x times minus 6, which is a minus 6x. When you multiply two things that have the same base, you add their powers. So power 1 plus power 1 gave me power 2. This doesn't have any variables, so that's just a negative 6 times that x. Negative 6 times x. But then we move on to the 5. And the 5 will distribute 5 times x. Well, that's a positive 5x. And then 5 times negative 6 will give us a negative 30. But once I'm done distributing, I have to add everything together. Oh, well, notice not everything here can be added. Because when you add polynomial terms, what you need to do is combine like terms. And not all of these are like each other. Okay, so we add what we can. These are like each other. We have negative 6x plus 5x. This doesn't have any other terms like it, though. There are no other x squares. Okay, so we leave that one alone. These two go together. Negative 6x plus 5x is negative 1x. If you want, you can just write negative x, or you can put negative 1x. Both of those mean the same thing. And then your minus 30 doesn't have any terms that are like it, so it's just going to stay as minus 30. And there we go. We multiply it out by distributing, and then you add things together. You combine like terms. So to multiply polynomials, what you're going to do is you're going to distribute. The same way we did up here, we're going to use distribution. Right? The process is called distribution. What do? We distribute. We distribute by doing distribution. We distribute, then combine like terms. Which is essentially what we've always done to multiply. If you have more terms than that, that doesn't change things. It just requires you to distribute a few more times. So for example, let's say I'm going to multiply together 2x minus 5 times x squared minus 16x minus 5. All right. Same thing's going to happen. We're going to distribute. This term will multiply across all three of these. Once, twice, thrice. All right. So 2x times x squared is 2x to the power 3. After all, x is like saying x to the power 1, right? Same thing over here. X is the same as x to the power 1. If we multiply 2x times the negative 16x, 2 times negative 16 is negative 32. X times x is x to the second power. And finally, we're multiplying across this third one. 2 times negative 5 is negative 10 times that x. You can write x to the first power, but usually people just write x. That means the same as x to the first power. But now that that one's been multiplied out, we can go on to this one. Negative 5 times x squared, well, that's minus 5x squared. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 16x, well, that's a negative times a negative. That's a positive. 5 times 16 is 80. and you have your x. And finally, you multiply this constant times that constant, negative 5 times negative 5, and that's going to give us positive 25. So now, as we saw previously, once you're done with your distribution, then you combine any like terms. Now, not every term will be like each other, so we're going to only go with the ones that can be combined. Notice right here, 2x to the third. There are no other x to the third terms, so just leave that alone, 2x to the third. These are like terms because they both have an x to the second power. So negative 32x to the second minus 5x to the second is negative 37x to the second. And then these two are like terms. You have a 80x minus 10x, which will give us a positive 70x. And then your constant doesn't have any other terms that are constant. It's the only regular real number. So that one stays as it is. And that gives us our result. So we multiply by distributing and then combine any like terms that you can find. Squares go with squares. First degree go with first degree, just like that. So go ahead and give this a try. Multiply the following polynomials together. Let's have you try 2x plus 3 times 5x minus 4. Go ahead and try and multiply together, let's say 2x plus 5 times 2x minus 5. And then let's do one that's a little bit bigger. Let's have you multiply together, let's see, 3x minus 2 times x squared minus 6x plus 5. All right? So go ahead and go through that. Go ahead and pause the video, multiply those out. And once you're done, go ahead and unpause and we'll go through it together. All right, so let's take a look. We're going to distribute here to multiply. 2x times 5x, well, that is going to give us 10x to the second power. If you multiply 2x times negative 4, that'll give us negative 8x. And then if you take the 3 times the 5x, that'll give us 15x. That's positive, so we'll say plus 15. And then we take the 3 times the negative 4, which is a negative 12. Now, the only like terms here are these two. They're both linear. They're both first degree. So those can be added together to give us 10x squared, 15x plus a negative 8x, or in other words, 15 minus 8. That's going to give us plus 7x. And that one doesn't have any terms like it, so we just leave that alone as a minus 12. And that is our result. This one will work the same way. 2x times 2x, well, that's going to be 4x to the second power. Okay. 2x times negative 5 is negative 10x. And then moving on to this 5. 5 times 2x is positive 10x. And here our 5 times a negative 5 is a negative 25. Okay. Note that here our like terms actually just give you 0. If you have 10x minus 10x, that's just 0. So you can write 0x, but most people just don't write anything. So here we write that as just 4x squared minus 25. You can write plus 0x in the middle, but generally people just don't write anything when there's a 0 there. And there is our result. Finally, we can move on to this third one. We take 3x times x squared. Now remember, x is like saying x to the first power. So that's going to be 3. X to the first times x to the second is x to the third. Right here. 3 times negative 6 is negative 18. X times another x, that's going to give us x squared. And then if you take your 3x times your 5, that's going to give you 3 times 5, that's positive 15x. But now we need to move on to this negative 2. Negative 2 times x squared, that's minus 2x squared. Negative 2 times negative 6x, negative times a negative makes that a plus. 2 times 6 is 12. And then that doesn't have a variable, so that's just that x on its own. And finally, we can multiply these together. A negative 2 times a positive 5 gives us a negative 10. But now we need to combine like terms. These are squared, so they're going to go together. And these have a first power, so they're going to go together. Notice that when we distribute, when we multiply, the powers come together. So when you multiply, powers change. But when you add, powers do not change. 3x to the third. These two go together. Negative 18x squared minus another 2x squared. Here only the coefficients change. When you multiply, variable powers can change. But when you add or subtract, only the coefficients change. Here the x squared stays as it was. Likewise here, you have 15x plus 12x. 15 plus 12 is 27. The variable doesn't change. All right, x times x is x squared. The power changes. X plus x is 2x. The power does not change, only the coefficient. So when you combine, you distribute, that changes some powers, but then when you're combining, powers never change. That's going to stay x squared. 15x and 12x, that's 27, but that stays x. And finally, our constant doesn't have any terms that are like it, so it's going to stay as it was, as a minus 10. Okay. Finally, the last thing we want to look at is one specific kind of notation that is still the same thing as multiplication, but it looks just a little different. And that's what happens when you square something. Let's say I have 3x minus 5, and I'm going to square it. Well, squaring means multiply it times itself. So even though this is written as a power, the way we evaluate this, the way we simplify this, is we're going to do what squares always do. We're going to write 2 copies of this base and then multiply those together. Okay? So once you've written it this way, now it's just the same problem as what we've seen already. If you take your 3x times your 3x, that'll give you the 9x to the second power. 3x times a negative 5, that's a negative 15x. Negative 5 times 3x, that's also negative 15x. Negative times a positive is a negative. And finally, negative 5 times negative 5. Negative times a negative is a positive. 5 times 5 is 25. So you can combine your like terms. Here, these are the only like terms. And we're going to get 9x squared minus 30x. Negative 15 minus another 15, that's negative 30, plus 25. So whenever you have a power, think of that power as repeated multiplication, and then distribute. Do the same thing we did over here. Do the same thing we do above to distribute. So as our last problem, go ahead and give that a try. Go ahead and take 2x minus 7 and go ahead and square that. Pause the video, and once you're done, go ahead and unpause and we'll go through it together. All right, so let's take a look now. One thing you should not do, you should not try to square each of these. That is not how a square works. That would work only if you had multiplication inside of here. If all we had was something like 2x times 7y, and that was being squared, notice that has no addition or subtraction inside. There's only multiplication. In those cases, then you can square everything in here. Here you could say, okay, that's 2 squared is equal to 4, and x squared, well, that's x squared, and the 7 squared, that's 49, and then the y squared, like that. And then here you could even multiply the 4 times the 49, and that would give us 196 x squared y squared. So when everything in here is just multiplication or division, that's when you can just square everything in here. But when there's any addition or subtractions, that's a polynomial. And when there's a polynomial that you're squaring, what it means is you need to distribute. So here, you can't just square this and square that and get the correct answer. You have to take 2x minus 7 times another 2x minus 7, do the distribution, and then combine your like terms. So let's see what that result is. If you take 2x times 2x, that's 4x to the second power. All right, 2 times 2 is 4. X times x is x squared. You can take the 2x times the minus 7, which is minus 14x. 2 times 7 is 14, but you got a negative there. Negative 7 times 2x is negative 14x. And finally, negative 7 times negative 7 is positive 49. Notice you have some like terms here which you can combine. So this will give us a final result of 4x squared. You have minus 14x minus another 14x. That's minus 28x. And then you have a 49 as a constant. So that's our result. All right. So that is it for multiplication of polynomials. That includes monomial with a monomial. That includes monomial with a polynomial and polynomial with a polynomial. All right. So if anybody has any questions, comments, or problems, please make a note of those and reach out. And I hope everyone has a nice day.